equation solving and modeling. So this should just be a lot of like solving exponential and some logarithmic equations. So number 2, I've got 32 times 1/4 raised to the x over 3 equals 2. And I'm trying to solve for x. So first thing I do is I need to divide by 32. So I have 1/4 raised to x over 3 equals 2 over 32 would be 1 over 16. This is supposed to be an x, not a 1/3. There we go. So then I do my log base. So I have an exponential. I need a log to solve. So it comes down through here, up and over. So I have log base 1/4 of 1/16 equals x over 3. Take this 3 and multiply it over here. So 3 times log base 1/4 of 1 over 16 equals x. And we need to plug that into your calculator and get an answer. So somebody plug that one in. So 6 is equal to x. Now, these problems say to solve and to check them. To check them, all we would do is take this number and plug it into the original and then basically just show that the left side is equal to the right side. I'm not going to require that you check them, but you are welcome to go back and check them if you want to. But just for the sake of time, we're not going to check them. Let's see, 6. 3 times 5 raised to the negative x over 4 equals 15. So divide by 3 first. So I have 5 raised to the negative x over 4 equals 5. Now, in this case, I don't necessarily need to use the log to solve these because these things have the same base. What does that mean about their exponent? They have to be the same. So negative x over 4 would be equal to 1. So I just need to multiply by negative 4. So x equals negative 4. So that one we didn't even need a log to solve. Now you still could have done it that way, but you would get the same answer either way. But that one's a little easier. So those are exponentials. We use a log to solve them. There's a few in this as well that are logs to be solved. So 10 log base 4 of 1 minus x equals 1. So to undo a log, we use an exponential. We start here at the base and we loop around. So this is 4 raised to the 1 equals 1 minus x. So 4 minus 1 is 3. Divide by negative 1. So negative 3 equals x. And just like the other problems, you could plug that in as well. If I plug in negative 3, that becomes 1 plus 3 in there, which log base 4 of 4 would just be 1 from the properties that you know. So that one's checked if you are just so inclined to want to check them. Hopefully, if you're using your calculator, As long as you get the setup right, you should be right. All right, the next ones are more like decimals and stuff involved, but it's like we're doing the exact same thing. So number 12, 0.98 raised to the x equals 1.6. So this is an exponential. We need a log to solve it. So we come down here, make the L. So log base 0.98 of 1.6 equals x. And then you just need to type that in. In 2 decimal places is good. The book will go out to 4 like they did in the section. I don't know if it was like yesterday or whatever, but 2 is fine. They don't like actually specify, that's just what the book does. So 14. 80 times e to the 0.045x equals 240. So first thing I need to do here is divide, because I want it to just be whatever being raised to the power like left on that side. So divide by 80 e to the 0.045x equals, what is that, 30? Yes, I think so. No, 30, not 30. So then now use a log to solve it. Now this is log base e, so I'm just going to write that as ln of 3 equals 0.045x. Divide by 0.045, so I'll have ln of 3 over 0.045. And type that in and tell me what that's equal to. .41. Uh, 18. 3 minus log of x plus 2 equals 5. What do I need to do first?
You need to bring the 3 on the other side.
Yep, so I have negative log of x plus 2 equals 2. Then what? Yep, so I'll have log of x plus 2 equals negative 2. So I'm at the point where I just have a log on the left, so how do I solve for x? Yeah, so we start here and we loop around and we make our e, and that tells us what order to do things. So this would be 10 raised to the negative 2 equals x plus 2. So then 10 to the negative 2 minus 2 equals x. You can just type that in and tell me what that's equal to, because it's going to be a decimal. Negative 1.99. Yep. All right. The next one say to solve the equation by the method of your choice, which is more or less what we've been doing the whole time. But some of them are going to require a little bit more effort to them potentially. So 26 ln of x squared equals 4. So this is a log base e. So start here and come around. So e raised to the 4 equals x squared. Now to get x by itself, I have to take the square root. What happens when I take a square root? How'd y'all miss getting a cookie point last year in Algebra 2? Plus or minus. All right, so this is going to be plus or minus the square root of e to the 4th, or I can rewrite this as plus or minus e squared, because e to the 4th, the square root of that would be e squared. So plus or minus e squared equals x. If you want to write them just as one thing like this, you can. If you want to do them separate, that's also fine. The book is going to actually give you an approximate number. So when you square e, you would get something around 7.389 or something along that. So essentially, that's the number that it would be. If you leave it as e, like, that's fine. But if you want to, like, get the actual number, that's also fine too. Like, I'll take it either way. But just so you know, if your answer has an e in it, the book may multiply it, it may not. It just depends. Okay. 38. Same instructions. We're just jumping some in the middle that are way harder than stuff that you need to be able to do. So 38, I've got log of x minus 2 plus log of x plus 5 equals 2 log of 3. So what's different about this one compared to the other ones that we've done so far today? Broken down. So any idea what I might need to do first before I go through and do the whole problem? Well, yep. So what you guys said together. So the log of a product is equal to the sum of the logs and vice versa. So I'm going to take these two things and multiply them into one. So I'm going to condense it. So I have log of x minus 2 times x plus 5 equals, what can I do on this side?
Log.
Yep, so that's going to end up giving me log of 3 squared is 9, so I'm just going to skip writing it as 3 squared and just do it that way. So now I need to FOIL this in here. What do I get when I do that?
X squared plus 3x times 10.
Yep. Any idea what the next step might be? See if y'all have any ideas.
Yeah, subtract the right side to get everything all inside.
So I don't need to do that. There's something else that I can do instead. So let me go back. When we had, let me find it. When we had this problem, these had the same base, so what did we say about their exponents? They had to be equal. So go down here. These logs have the same base, so what must be true?
X squared plus 3x minus 10 equals 5.
Yep. So I can just get rid of the logs because they have the same base. If they were different, I wouldn't be able to do it this way. But they're not going to give you a problem like that. So this is going to be x squared plus 3x minus 10 equals 9. I'm going to subtract the 9 over so I can get it equal to 0. So x squared plus 3x minus 19 equals 0. Now, at this point, you can hope that it comes out to something that's going to factor. This one does not, because the only factors of 19 are 1 and 19. So, what do you think I might need to do? Quadratic formula. Yes. So, quadratic formula, I'm just going to write it up here because it's been a little bit since we dealt with it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I just need to plug this stuff in to solve for x. So, negative 3 plus or minus the square root of 3 squared. So, I'm just going to write that as 9. Minus 4 times 1 times negative 19 all over 2. Zoned out there for a quick second. So then I'm going to end up with 2 separate things. But let's see. Nope, not that. 19 times 4 is 76 plus 9. So this is going to be negative 3 plus or minus the square root of 85 over 2. Now, they're wanting specific answers, so at this point, you would just need to type this in your calculator and get the 2 separate answers. So I'm going to type in negative 3 plus the square root of 85 over 2, and I'm going to type in negative 3 minus the square root of 85 over 2 and get those answers. I'm going to show you, I'm going to scroll back up in just a second, but I need to turn this on so you can see it. I want to make sure that you guys know the little, like, kind of trick, easy way to plug this in without having to type it in multiple times. So if I hit alpha y equals, that brings up the opportunity to type something in as a fraction, so I'm going to do that. Then negative 3 plus the square root of 85 over 2. So you can type it in like that, and that's going to give us our first answer is 3.11. Then if I want to, if the only thing I need to do is change this negative sign in the middle, and I'm like, I really don't want to retype that again. If you hit second and then the enter button, you'll notice above it, it says entry. That allows you to type basically the exact same thing you just had again, or like, let's say you type something in, you're like, oh man, I typed a sign wrong. You can do that, and that'll be kind of, you can go back and overwrite it. So I can just arrow over to what I need to change. So I'm just going to change this to a minus, hit enter, and I get negative 6.11. Now, everybody okay on the calculator thing? I know some of your calculators may not do what I just did, but we're okay with that. Okay. All right. Now, this tells me that then x is equal to 3.11 or x equals negative 6.11. But much like we had in the last chapter, where we are, that last chapter or earlier in this chapter? Last chapter, I think. Extraneous solutions. I need to make sure that if I were to plug any of these numbers in, it's not going to cause a problem. Okay? So the big thing that causes a problem is a negative in a log. So I need to make sure that whatever number I choose isn't going to cause a problem. 3.11, when I plug that in, that's still positive. That's still positive. So this one is good. Negative 6.11, if I plug that in, that number is going to be negative, so that automatically is a problem. And even if I plug it in over here, also a negative, that's going to be a problem. So this one would be extraneous, okay, which you don't necessarily have to write with these ones, but the only answer that actually works is 3.11. Okay, so you just need to, you don't have to like check the answer, but you need to go back and look and make sure that it makes sense in the problem. Okay. Where are we at? All right, this little thing is kind of more just like, I don't know, fun information for you. I don't really know how else to put it. If you take physics, we do like one little like section on this topic. So, anyways, take it for what you will. But it's order of magnitude. And so it's kind of like how many orders of magnitude do the quantities differ by. So it's, in a sense, it's like powers of 10, kind of. But if we have something like 42, it says lemon juice with a pH equal to 2.3 and I'm going to say root beer. You can guess what the problem actually says, with a pH of 4.1. And so all I do when I'm given these numbers is I subtract them. So, like, it's super easy. So 4.1 minus 2.3, what would that be? 1.8. And that would be the order of magnitude for that problem. Like, the amount that it differs by. Now, this next one's tiny bit different. So, the sound intensities, which this is where it more so comes in to physics class, but of city traffic at 70 decibels and rustling leaves, perfect for this time of year, at 10 decibels. So I take these two numbers and I subtract them. So 70 minus 10 would be 60. But order of magnitude needs to be things that are like powers of 10. So this would actually just be an order of magnitude of 6. Okay, basically you just take the 0 off. We want like whole digit numbers, like single digit numbers. So they're not like anything super crazy. The only ones that you really end up getting stuck doing something like this is if it's like decibels, because they end up being bigger numbers. But if it's like pH or like Richter scale for like earthquake, stuff like that, it's pretty much just going to be just subtract them and you're going to get your answer. So if you're like, I have no idea what this is relevant to, I don't use it in real life other than in physics class. So anyways, any questions on any of this stuff? All right, problems then are 1 through 17, every other odd. I think 17's included. If not, then end on 15, you know, however that rolls. And then 25, 37, and 41.